Hello, good day. Once again, you are welcome back. In this class, we're going to look at this integral before us. Integral lnx divide s raised to power 6 dx is equal to, so we should show it that is equal to minus 1 over 5 s raised to power 5 open bracket lnx plus 1 over 5 close bracket plus c. Okay, first thing we have to look at here, how do we go? We have to look at this ln x here. So we have to let it to be another variable. So here we say let g is equal to lnx, so that in place of lnx we substitute g there. Okay. Now since we have let g is equal to lnx, it means we have to look for an expression for the x and x, so that we take also the variable of g. So by so doing, ln s is the same thing as log x to base e. So and the g here, we can also express it since uh, this is log x to base e, so that it will become log exponential g uh, to base e. Well, if you cancel out log to base e, log to base e, s is equal to exponential g. So it means I'm just trying to find an expression for x. So x here is exponential g. So to obtain the s, we have to differentiate this, which is the x over the g is equal to exponential g. So once you find the derivative of exponential uh, to any function, which is just a single variable here, is that same exponential g. Okay, so the s is equal to exponential g dg, and we also know that x is equal to exponential g. So we substitute it in place of the x, we substitute this. In place of s, we substitute exponential g. And the expression become exponential g times g divide exponential 6g times the g. So here, this exponent here, this is the base and this is a base. So we apply the laws of indices here, since this is division. So this become as integral g exponential open bracket g minus cg close bracket the g. So the expression is typically reduced to integral g exponential minus 5g or the g. Here we can see that we can separate this. This can be g times exponential minus 5g the g. This is typically the most appropriate techniques here is integration by parts. So we definitely use that. And here the integral becomes the integral of v du is equal to minus uv is equal to u v minus integral of v du. This is the formula for when you are differentiating when you are integrating uh, products, a function that is a product. So what we need to do, we say v is equals to g and the u is equals to exponential minus 5g dg. So for us to obtain the v here and also obtain u from this expression, we differentiate the v, the g is equals to 1, so that the v is equals to the g. Then to obtain u, we have to integrate both sides and we apply the integral sign to both sides. Then integral du is equals to integral exponential minus 5g dg. The integral of the u is the same, is equals to u. Then to integrate integral exponential minus 5g dg, first we say let this power here, this exponent here is equals to r. Say let r is equals to minus 5g, so that the integral will become exponential minus r. We are doing this because um, we need to use substitution so that we be able to find an appropriate integral for the whole of this term. Okay, so here we have seen the arrow is equals to minus 5g and the integral is equals to exponential arrow dg. So we need to eliminate the g so that we have the arrow here by differentiating arrow is equals to minus 5g. So the arrow dg is equals to minus 5. Then to obtain an expression for the g, we can multiply both sides by minus the g over 5. The arrow over the g times minus the g over 5 is equal to minus 5, which is here, times minus the g over 5. And if that is on minus 5 cancel minus 5, this become the g. Then on this side, the g cancel the g, here become minus the arrow over 5. So in place of the g, we substitute minus the arrow over the 5, so that the expression here can be all variable that involve r. Okay, so here we can easily integrate. And to integrate exponential arrow is the same thing as exponential arrow. To integrate this with respect to the arrow is also as known as exponential arrow. So this becomes minus 1 over 5 exponential arrow. But here we said, we recall that r is equal to minus 5g, so we substitute it here, so that the integral of exponential minus 5g dg is equal to minus 1 over 5 exponential minus 5g. Okay, that is u now. This is the integral of u. So u is minus 1 over 5 exponential minus 5g, and our v is equal to g, like we said earlier. So we substitute it in the formula on the right hand side. So our v is g and u is minus 1 over 5 exponential minus 5g, close bracket, minus integral on this, which is this integral, u is minus 1 over 5 exponential minus 5g, and the v is what we said. The v is equal to, we look at here clearly, the v is equal to the g, so we will substitute it here, and this will become the g. So minus times minus here is plus. Then we factor out this constant, so this becomes 1 over 5. So the expression become minus 1 over 5 g exponential minus 5 g, okay, plus 1 over 5 integral of exponential minus 5g dg. So we have also obtained the formula. We have also obtained the formula if we integrate the integral of integral of exponential minus 5g dg is equivalent to this. If we integrate this, it's going to give us, so quickly we substitute it in this part of the formula, okay, of the integral. Okay, so this become minus 1 over 5 g exponential minus 5g plus 1 over 5 into minus 1 over 5 exponential minus 5g. So here minus times plus become minus 1 over 5 times 1 over 5 become 1 over 25 exponential minus 5g plus an arbitrary constant. So this side is already worked out. So this become minus 1 over 5 g exponential minus 5g minus 1 over 25 open bracket exponential minus 5g close bracket plus c, where c is an arbitrary constant. So here, if you look at this same here, you see 1 over 5 here minus 1 over 5 is a constant, so we can factor it out, and exponential minus 5g. So if you factor it out, what will be left in this part will just be g. So minus 1 over 5 exponential minus 5g open bracket g plus 1 over 5 close bracket plus an arbitrary constant. But we said that initially that g is equal to ln x. So in place of g, we substitute ln x. So here the integral become minus 1 over 5 exponential minus 5 ln x. Okay, open bracket ln x plus 1 over 5 close bracket plus an arbitrary constant. Here, if you look at this carefully, we must have to do some workings here. This is one of the principle or laws of indices. So minus 5 here have to move this way. So here minus exponential minus 5 ln x can also be expressed as this. Okay, as exponential minus 5 ln x, I mean log x to base e. Here, this minus here will be transferred to this side as power, so it will become exponential minus exponential log s raised to power minus 5 to base e. Here, in logarithm, if the power here, if we have the power that raises the base and the power and the base of the logarithm are the same, the whole answer is just s raised to power minus 5. So the whole of this expression is s raised to power minus 5. So that if we substitute it on this part of our equation here, this become minus s raised to power minus 5 or divide by 5. So if you apply the principle or the laws of indices, this become 1 over 5 minus 1 over 5 s raised to power 5 open bracket ln x plus 1 over 5 close bracket plus c, where c is an arbitrary constant. So this is how to handle these questions. We can see that we have shown it clearly. Please, if you like this video and you want to see more of it, help subscribe and also hit the notification button. Once a similar video like this come up, you'll be able to have access to them. Have a nice time. See you in my next workshop class.